Well, good afternoon, everybody. My name is Jim Gossett. I'm a PDI member and past PDI president. I work for Raccoon Valley Electric Cooperative, and we've got some utility professionals today who have put together the second session out of three of Powering Iowa's Landscape. We're trying to provide to economic development professionals, PDI members in the state, a way to learn more about how power is delivered to your project. We've got a great three-part series. Last week had a lot of participants. We've really done a good job. I think those panelists have kicking it off. We've got a few different panelists today I'll introduce here in just a moment. But this is a product of the PDI Education Committee, who in some of their meetings, and I think after one of the PDI conferences, put their heads together and said, we'd really like to know a little bit more about how the power is delivered. And the utility professionals on the panel and in support of this series from investor-owned utilities, municipal utilities, and electric co-ops to also our transmission company providers have really got together now and put together a good session for you. It's going to be conversational in a panel type situation, but then we're also trying to leave plenty of time for your questions. So I will just begin by saying I've been in your shoes. And many of the utility professionals in Iowa, as you know, have either been in and operated an economic development organization in a local, county, regional role. But my story was I ended July of 2013 working for Carroll Area Development Corporation. We had just broke ground on a $17 million expansion at a company. When I went to the next day to Raccoon Valley Electric Cooperative, they were our second largest account. So seeing both sides and really not always knowing exactly what to talk about when we talked about electricity, but to leave it to my utility professionals, which is still the case in our projects. We were talking about how this gives us just a better common knowledge. Think about it like this. We all know about TIF, tax increment financing, but we still rely on the bonding attorneys and the experts to take us through the projects. That's what we're trying to spread about delivering power to your project. So we're going to kick it off today with our panelists. And I'm gonna name them one at a time. If you would jump in, please, panelists, and give us a very brief introduction, your name, where you work, maybe how long you've been in the business. We'll start with Bruce Hanson.
Thanks, Jim. Bruce Hanson, Vice President, Business Development for Iowa Area Development Group. We work with the Rural Electric Co-op, Municipal Electric Systems, and the independent telephone or telecommunication companies across the state.
Thanks, Bruce. Emily Kaiser?
Good afternoon, Emily Kaiser. I am a senior key account manager at Alliant Energy. So I focus on serving our large commercial and industrial customers as well as economic development in the Cedar Rapids area. I've been with Alliant for 7 years now. However, prior to coming to Alliant Energy, I served economic development in Benton County.
Super. Thanks, Emily. Sherry Monahan.
Hi, Sherry Monahan, the Director of Customer and Business Solutions for ITC Midwest, basically supporting and aligning our economic development goals with our largest customer and any of those utilities connected to us. Been with ITC for 2 years, but before that, I worked at SIPCO, the largest G&T in the state, and so very familiar with the G&Ts that are in the area and the rural electric cooperatives. I was with them for over 13 years. So really a pleasure for me to be here today with you.
Wonderful. Glad to have you. Last but not least, certainly, Sam Wagner.
Oh, least. Yeah, definitely least. Sam Wagner, I'm a business and community development manager with Mid-American Energy. I'm officed in Sioux City, Iowa. I've been doing economic development for over 20 years. So like Jim, I've kind of worked both sides of the fence. For the last 6+ years, I've been doing large project development work for Mid-American Energy. So I work on all the large industrial projects, data center projects. On the project development side, I do a lot of community development work as well.
Super. That's great. We're ready to go. So, you know, in the first session last week, we learned from Amber Rogers and the Iowa Energy Center team more about Iowa's power landscape, the resources and trends. That was a very informative discussion. And if you missed it, PDI, it'll be recorded, it is recorded and on the PDI website, as will this one and next week's webinar as well. So now it's time to get down to the business of how the power is delivered to your projects. Sam, can you walk us through a little bit about how we get power to a project in Iowa? How does it flow from generation to the customer?
Sure. So we're going to kind of cover this. This is Power 101. So how does it get from a generation facility to your home or to your business, to your factory? So starting with the generation, I mean, we have to create electricity somehow. Here in Iowa, primarily we generate electricity through our thermal generation fleet, coal plants, natural gas plants, and wind energy. We also have a little bit of solar in Iowa, and with Mid-America, with our generation mix, we kind of take this all of the above approach, where we have a lot of different types of generation to actually produce the electrons that we then have to deliver to the end use customer. And so, coming out of, as it comes out of the generation facility, and again, that could be a wind turbine, that could be a solar panel, that could be a coal plant, doesn't matter. Once the power is generated by those facilities, then basically what we have to do is we have to distribute that power, transmit that power over typically longer distances at really high voltages. And it's a whole process of jacking up that voltage to a really high voltage. So you might hear these terms 69 kV transmission line, or 161 kV, or 345 kV. Those are the voltages that we pump that electricity up to be able to transmit that energy over longer distances. That's the transmission system. So when it comes out of the generation plant, it goes to a substation, and through the magic of substations, which I won't get into, we crank up that voltage to a predetermined transmission voltage, and then send it on down the line. And those are the big giant power wires you see coming out of a generation facility, or just through a farm in the field as you go through Iowa. And so through a network of substations, we keep that voltage up, but eventually we got to start stepping that voltage down into the distribution system, and that's where distribution substations come in. And you hear us utility folks talk about substations quite a bit. This is typically what we're talking about, our distribution substations. So the transmission line comes in on the high side of the substation, and then we have power transformers that transform that power to a preset distribution voltage. Could be like 13 to 13.2 kilovolts or 13.2 kV. And then those go over the wires, the typical utility poles that you see all throughout town. Sometimes they can go underground as well. There's increasingly these days, there's a mix of above ground and underground, but eventually we have to transmit that power, or distribute that power to the end use customer. And we go through a series of smaller and smaller transformers, some of which just look like green boxes on the end of your cul-de-sac. It could be something like that, where for a home, we continually step that power down to the point where we're delivering that power at 240 volts. So we're going from, say, 161,000 kilovolts or whatever that is, down to 240 volts to feed your house. Or for a commercial or a small industrial, could be delivered at 480 volts. For larger factories, that could be at 480 volts, or for specialized equipment, 4160 volt. Whatever the end use customers needs, we can kind of put the right transformers in place to end up delivering that power. So really, that is the journey from where the power is produced to delivering, transferring that power over long distances to how it's delivered to the end use customer.
Super, Sam. Great. Any of our other panelists have anything to add on the physical system and the process of getting it from generation to the end user, as Sam has started to outline it? We're going to talk more about what's a kilowatt here in a minute. We're certainly going to hear more from Sherry a little later about some more intricacies of the transmission system. But for now, Emily, Sherry, Bruce, do you have anything to add?
I kind of like the analogy of the transmission system being like your 4-lane highway, needing to get a lot of electrons over a long range. So you wouldn't necessarily, unless you were on a fun Sunday drive in a convertible, go on side streets. You'd take a, direct route, to your community. And then once you get to the community, that's when you've got those side streets and you're meandering throughout your community. So I'll use that analogy when I get to my point. So I just wanted to make that that 4-lane highway as far as the transmission system.
Great.
And I want to
Great
add to that,
analogy.
because I think that's a really good analogy. And you could take that even a step further by saying, you are not going to put your house and its driveway on the interstate,
Right.
right? And so, for the transmission system, we don't serve customers off of the transmission system. That transmission system really is about, just as you said, it's the 4-lane highway that transmits electricity over long distances. The distribution system, that's where you have the driveways onto the system to deliver that power. So that's a great analogy.
Super. Anyone else?
Nope.
Great. Okay, before we move on, I want to point out that the chat is open. If you have a question specific that we can answer during a section of this session or at the end, we're happy to do that. So please put those in the chat. You'll also find on the PDI website, and Carly, I'm not sure it's on just yet, but it will be after the session. You'll hear some acronyms, you'll hear some terms. We've got a list of just almost 100 electric and power terms in a glossary for the membership that will be posted to the PDI website. So as you're taking notes, as you have certain questions and you want to go back, we'll have that available for you as well. Bruce, for the developers that aren't involved directly in electricity, can you tell us more about a little primer on how we measure electricity and what's important for a developer to know?
Sure, Jim, and I'll just echo what you had mentioned starting off the series is, I'm glad we're doing the 3-part series, because I remember 30 plus some odd years ago sitting in my first REC meeting, and they started talking about kilowatt hours and demand. And then I think in one of our committee sessions last week, I said they started talking about electric heat and a plenum heater. And I said, well, what in the hell is a plenum heater? I had no idea. Anyway, so this is great. And I'll just, try to in basic terms of electricity, kilowatt hours is the energy part. kWh is what it's more commonly known as, and that's the energy component, and it's basically a measurement of electricity. And so when you think about well, what's a kilowatt, the best analogy, and I think we even have it in the glossary terms, you think about a 100-watt light bulb operating at 10 hours of usage, that equals 1 watt. Well, homes, average use of a home, and that's what take a look at your electric bill when you get home tonight. Average use for a monthly use on a house would be anywhere from 800 to 2,000 kilowatt hours a month. Now it's going to vary, of course. What do you have plugged in? Are your kids leaving the lights on? Is the refrigerator door open? You have all sorts of variables with that, but essentially it's a use measurement of electric usage. And so then you have to ask the obvious, well, how many economic developers does it take to screw in a light bulb? Well, we hope it's one, right? That's right. So anyway, the next item that you're going to hear more commonly used is demand, kW demand. And that is a measurement of the usage demanded upon the electric system for that location. And demand is measured in a 15-minute interval. When companies are using equipment and using everything at once, they may set a demand for that month in that 15-minute, and it's always reset every 15 minutes on a demand meter. And so that's something to keep in mind, is that demand can change for that usage or that user, that commercial user. Demand is not commonly used at a residential level, but at a manufacturer or at a warehouse or cold storage facility, that type of thing, you're going to see a demand charge, and that demand is usually set every month on 15-minute intervals, and that's going to change every month as well. And then I guess moving on beyond that, you have megawatts. And so from a megawatt standpoint, that's larger users. I think Sam had mentioned, data centers and larger manufacturers. Then we're talking about some major installations of power that larger substations and so forth are coming in with a megawatt hour. So.
What do the others have to add to this part of the explanation of kilowatt hours and a little bit of introduction into the demand charge? We're going to dig a little deeper in that as we go through our program here, but as a starting off point, Sam, Sherry, Emily?
Jim, could you go back one slide? For the demand charge, I just want to mention for customer A, you could probably serve them at a lower voltage. And for customer B, who's only using the system, but look at their 500 kilowatts of demand, you have to put in larger wires, which requires bigger poles, more concrete. And they're not utilizing the system very well because they're just peaking and then not using it, but peaking and not using it. But we still have to put those bigger assets in to serve customer B, and therefore customer B, which we wrote at the bottom, which customer requires more investment in the system. Customer B for sure is going to have a higher demand charge because they're not utilizing the assets that we put in place to serve them, only certain times. Maybe it's only 30 minutes out of the whole hour that they're at 500 megawatts, but we have to have those assets there to serve them at that level.
And then you're getting into load factor and efficiency of that power being used. So that becomes you're actually getting to a lower cost per kilowatt hour with a higher load factor being more efficient. So your
load factor right and
is matching your demand use, or is used more efficiently.
Precisely. And this is a very good point that they are making to our participants, that the panelists are making, because this is precisely why you need your energy advisor and your economic development person from your utility to be involved as early as they can. These people can counsel your new prospects and into some more efficient energy use. Sometimes perhaps getting back to maybe that 500 kW demand needs to be could potentially be less. And so there's a lot of things these utility providers can do to help your prospect understand and better use the energy. We're not about building it just to build it.
So Jim, on that, from a demand standpoint, I always remember this, from years ago when the operations, we'd get together with the operations guy to meet with the key account, and the key account manufacturer was turning everything on at once, and they'd set their demand, but they didn't realize that they would alternate usage because they didn't need to have everything on all at the same time. They could alternate usage and control that demand much more easily by staging things or soft starts or whatever that might be. So they can control that demand and lower it perhaps. So
great. Emily?
And I'll just add that, this really impacts the customer from a billing perspective as well. So as we talk about them hitting their peak demand, that's what they're billed for. They're billed off of that peak KW that they hit on a monthly basis. KWH is measured throughout that entire billing cycle. So they're really two different bill components. So when we talk about load factor and what this does to load factor, when you have more kilowatt hours to spread across that peak demand, it lowers that cost for KWH as well.
Great. Sam, can you put a little finer point? Is there anything left to be said about what expectations that these decision makers for a project have when it comes to electric service? What should the developer know to do, and maybe a couple of simple questions to ask to get them kicked off into helping the decision maker with a location? Sure.
So, ultimately, a developer, if you're working on an RFI, you're working with site selectors and a end use prospect. really they're going to want to know three things. They're going to want to know what needs to be built to serve the thing that I want to build. They want to know how much is it going to cost me to do that, and how long is it going to take to do it. Right? It's pretty basic stuff. That hasn't changed. Right? There's a lot of other things in this business that, that's changed in recent years, but those core things remain exactly the same. So, okay, so what is, so what, as a utility, right? We're going to look at this and we're going to, okay, you want to build let's just say a factory. Okay. Well, we're going to need to know some things before we can tell you the answer to the very key core questions that that you have. This discussion, even just now, talking about demand and load factors, demand charges, and so on and so forth. Somebody comes to us and they say, "Hey, we need 5 megawatts for a factory. Let's go." Okay, I think even just that little thumbnail discussion that we had just now about the demand and demand charges and load curves and all that stuff. What that doesn't tell us, if somebody comes to us and says, "Hey, but just need 5 megawatts," what that doesn't tell us is how are they going to use that load. And so what we do is we start off with a series of questions, and this is where we can start to become helpful and useful not only for the economic development partners we have, but also for the site selectors and the prospective companies, because we start to ask some questions that help us gain a better understanding of not only how much power they need, but how they're going to use it. And so, if anybody has worked with me, I'll send you, or any of my colleagues at MidAmerican, we have a load questionnaire that we put in front of a prospect. And I'm the first to admit, if you see that question, it's like 20 questions long. If we can get a quarter of that, if we can get what their peak demand is, if we can get what their hours of operation or load factor are, and what their nominal usage are, we can really start to dive into a load study. And that's really what we need to do next is take that information that we get, go through a load study with our team to make any determinations on system upgrades that may need to happen to serve that load. And what would need to be constructed, right? Lines extended, transformers placed, substations built for the really big stuff, that kind of thing. And really, that's where we come back to them and say, answer that second question. Okay, what needs to be built? Well, that's where the load study comes in, and the results of that load study, we can start to answer that question. And then how long is it going to take? For a lot of projects, honestly, for most projects, the turnaround times on these things are usually pretty modest if we're just extending part of our distribution system. If we get into some of these larger projects, like larger, more complex industrial projects or data center projects, which are the most complex, where we have to build substations, where we have to do transmission extensions to feed those substations. Those timelines now for a substation construction project are pushing 36 months these days. So we really have to know that load information really on the front end to then turn around and present the decision makers the answers to these three key questions. And then increasingly and we'll talk about this I think a little bit later, but I'll just introduce it briefly. A lot of customers want to know where their electricity is coming from. How is it generated? And they're asking a lot of questions about renewables. And so I would even add that as a fourth question that decision makers are going to want to know. So those, so really, when you work with your utility partner, invariably the first thing we're going to do is start asking questions. And the reason for that is because we need the answers to at least some of those questions to turn around information that's useful and actionable for the prospect, for their site selectors, and ultimately for the community that's competing for these projects. So it can be an incremental process, right? It's not just a question and answer session. It can evolve over time. Next week's session that I know you all are going to be on, we'll actually take a much deeper dive into this into this piece of it. So commercial for next week.
Excellent. Good job. I would point out that none of us take for granted that a decision maker for a project is all that sophisticated in how the power gets to their building. Once the power is in the building, they may be more in tune with what they need and what they need to have that power distributed throughout the building, which is after the meter, for example, and really past what it is that we would be responsible to be technically involved with them. Not that, but we have questions around what goes on inside, not specifically, but what is it that how much power do you need in certain areas in total rather for the building. But we don't assume, as I said, that we don't assume that they're all that sophisticated about how power is delivered to the site. And to a great degree, sometimes they don't care. They want it. They want it this, they have a timeline and they want to know what's going to cost them. So Sam, that was a great recap. Emily, can you and the rest of you jump into, Sam mentioned something about how the power is generated and the renewable aspect of this. It seems to me that's not in the prospects we deal with, that doesn't seem like it's an afterthought any longer. It's not down the page for them, sometimes up high on the list. Can you talk a little bit about your experience with that?
Yeah, absolutely. So as we think about what customers desire, first and foremost, they have a desire for reliability and safety. So they want to make sure that whatever the electricity that's delivered to them is a highly reliable source, to make sure that if it's a manufacturing organization, that they're able to continue putting that product out. So at Alliant Energy, we really focus on making sure we have a diverse energy mix that includes, so we do have reliability at all times. Our goal is always to make sure power is flowing at all portions of the day. So obviously a big part of that, after reliability and safety, really comes that sustainability. More than ever before, we are seeing customers not like to have renewable energy, but require renewable energy as part of the generation portfolio of what they're receiving. So currently Alliant Energy is about 50% renewable from our generation portfolio. So most of that does come from wind. There's a little bit of solar, and we'll see that solar percentage continue to increase over the years. In addition, Alliant Energy also has a goal to achieve net zero GHG from utility operations by 2050. So that's really our approach of how we're looking at generation of the future. In addition, we understand that customers have goals that are far more aggressive than utility goals that we've established for ourselves. So we've identified a number of customer-focused programs for customers to be able to really close that gap. So for example, for a large user that, again, has to meet about 50% of their usage, we have a program called Renewable Energy Partners that we essentially develop a project and then transfer that PPA to the customer so they can continue receiving the benefits, both in the bill credits and renewable credits for that generation asset. Lastly, we know that customers need a way to track their renewable energy. So we also have what's called an Electing Customers program, where renewable energy credits, or RECs for short, are retired on behalf of customers based on what's currently within our generation portfolio. So again, we can share with customers that 50% of our generation portfolio, so 50% of their usage comes from renewable sources, but they need a way to track that. So that Electing Customers program is our way to show a customer a receipt for their tracking purposes for that renewable energy.
Super.
Yeah, and
go ahead, Sam.
yeah, I want to dive in a little bit on this as well. Emily hit it on the head here that this, people want to know where their electricity comes from, right? I mentioned that earlier, and it used to be renewable energy, or 100% renewable, or 50% renewable, something, whatever, was a nice to have, right? That was the case maybe 10 years ago. So if you could deliver on that, kudos to you. Now it's a requirement. and it's a front page requirement. And there isn't a project that I haven't, there's not a project that's come across my desk in recent years where renewable energy doesn't factor into that. So, Mid-American, I can talk a bit about Mid-American. We've been in the wind business now for about 20 years. We've invested about $14 billion and counting on renewable energy, primarily wind turbines, which you see all across Iowa. And that's gotten to a point now where those wind turbines are creating what we call base load generation, right? So, and basically what that means, if it's not blowing over here, it's probably blowing over there. Okay, and if you put enough wind turbines and spread your bets, you're not going to see this, peak and trough, peak and valley, depending on weather conditions. You're going to have a pretty solid base from which you can plan your generation assets, so what that's meant is that 61% of our pie chart, if you look at a pie chart, about 61% of our generation comes from wind, but how we actually use those wind assets is what's really important. And so we have a program called our Green Advantage program. And each one of those wind turbines, when they spin, they generate a renewable energy credit. And there's a marketplace for those renewable energy credits. And so what we do is we actually retire those RECs on behalf and claim those benefits on behalf of our entire customer base. So we don't sell them or put them on the sell them to sell access to the RECs to individual customers or anything along those lines. What we do is we retire them on behalf of our entire customer base. That means that every customer that we have gets to enjoy the benefits of the renewable energy that our wind turbines and solar installations provide. And so what we do is we have a program with this Green Advantage program. What it does is after we retire those RECs, we can do the math, and we work with the Iowa Utilities Board on an annual basis to do so. We basically take our annualized customer demand, so we know how much that demand is, and then we can calculate how much of that demand was met using renewable energy, and that produces a percentage. And that percentage has been kind of going and going and going. I started here, I think we're at about 58%. We're patting ourselves on the back. In 2022, and there's always a year lag on these numbers. In 2022, we actually hit 100%. So what that means is 100% of our customers' demand on an annualized basis was met with renewable energy. Yes, we still have coal fleet, we still have natural gas fleet, but we don't run them like we used to. We actually just kind of use those when it's necessary, and most of our base load is coming from our wind. And so when you compare that to how our demand is actually, demand is out there for how they actually use that energy, we're actually able to meet 85 to 100% or even over 100% of our annualized customer demand with renewable energy. And they can take this percentage, since it's not just Mid-American saying, hey, yeah, we're 100%. It's actually verified by the Utilities Board. What we're finding is that companies from the largest users that we have, or customers that we have, all the way up and down various supply chains, they can actually take those percentages and apply it to their own renewable energy requirements. So whether if they have a greening supply chain and they have to show that the energy that they're making their widgets out of is green energy, they can take this percentage and they can use that, and it's actually got some value in their own marketplace. It's proven to be an extremely effective strength for companies looking to locate in Iowa, expand in Iowa, to have access to renewable energy. So yeah, it's a big deal these days, and that's one of the ways in which we're kind of meeting that demand for renewable energy.
Thank you, Sam. Hey, Bruce, now let's come at this. That's a great segue into, regardless of the generation source, we still want to be able to have developers understand what these companies are looking for, and how do we get at what and how much power for how long, do they need? Can you briefly take us through what it takes to find that out? I'm thinking of your of your words around connected load and those kind of determinations.
Sure. You know, when you start talking with companies or projects, go from the analogy that we talked about earlier about a home, to a daycare, to a hotel, possibly, to meeting space. It used to be when we were talking about a megawatt hour, everybody would get excited about a megawatt hour. Well, shoot, now you're seeing multiples of megawatt hour projects, come across. But still, when you start looking at a daycare facility or a hotel, you might be from 25 kW demand up to 50 perhaps. When you get into manufacturing, you might be getting into 200 kW demand up to 500, possibly even a megawatt, just depends what's there. And so I always remember the operations folks and the engineering folks that I used to work with, over the years, it was, what is the connected load? That'd be a great question for anybody to ask. And a fair question for anybody to ask, and they may or may not know, and that's fine, but they need to, at some point, be able to demonstrate what that connected load might be and what are the motors that they're running for conveyor belts, for, bending presses or whatever that might be from a manufacturing standpoint, and even the compressors for a cold storage facility or, warehouse facility, whatever that might be, or whatever that might entail. But that's always been a key question, I think, is what is the connected load and what is expected? And then you can talk with your utility folks, your utility partners about, here's what you have, and then, you try to verify it from there. But, across rural parts of the state, you're not going to have a mega mall or that kind of project, but you're definitely going to get into, maybe it's that hotel or that convenience store or that manufacturer that is going to be possibly 200 kW demand up to a megawatt pretty easily. But as we've mentioned earlier, the data centers that are out there and those other projects that are finding their way into rural Iowa, there are some substantial loads that may find their way out there as well. So.
Great. So to repeat, Bruce, connected load really means if you run everything at once, that's your connected load, basically, to the developer. That's what we can say, right?
Exactly. Everything on at once. And here, because, back to what we were talking about demand, what the system has to be able to match that load that is demanded upon it. And so, that gets into the transformer size, that gets into, can the substation handle it? All those types of questions. But I think that's a great first question to ask anybody, any project you're working on is what is that connected load?
Super. Okay. Before we move on to transmission, Emily, can you add anything else for us about the best way for the developer to be ready to learn how much power is needed by a prospective user? And how do we involve more the utility provider in that? I know we touched on that around. I just want you to kind of cap that off before we move to transmission, if you could.
Yeah, absolutely. So ideally, in the most perfect world, the utility provider would be involved ahead of any project. So really, the utility provider is going to be your partner as you even work to identify sites within your community. So assuring that your utility provider knows the area in which you intend to market for additional industrial development is really going to be highly beneficial to both you and the utility as you guys work to attract this project. So that allows the utility to do some of that research on the front end. So where would we serve this? What's the capacity of the substation that would serve this site? How would we need to extend the line? And if we did, how long would that take? Those types of questions. So again, it's really best to really ingrain your utility representative as a part of your traditional economic development everyday operations because of those aspects. There are also levers that the utility may play. So again, for example, if by ingraining your utility provider within your community, they will have a better understanding of other operations within your community. So one of the opportunities of involving a utility provider early is identifying if there's opportunities for the utility to provide a rate incentive to that customer. So again, we can only provide that if there's non-competing customers throughout our service area. So the more we know about what the operations of the project are and what the operations within your community are, the better position we'll be to be able to know if we're going to be able to offer that incentive. So those are just a couple of the key reasons why it's important to involve us on the front end. And again, we're always happy to even have exploratory conversations, just as you prep your community or as you look to identify sites that you would like to further develop. You can always run that past us to say, hey, is this a good site? Is this a good site from a electric power perspective?
Let me jump in
That's
here real quick,
excellent.
because
Yeah.
Emily, you make just an outstanding point there. And I would add to that, that's the kind of thing you got to do in the off season, right? You don't want to, you don't want to start to have those conversations when you're responding to an RFI, if there's a project that's, that's pending. This is the kind of thing that you'd want to do, like I say, in the off season, not during game time. And I think this is also a really good segue into the certified site program, the IEDA certified site program, because that's a process that will necessarily involve not only your electric and gas utilities, but all of your utilities. And you go through that whole due diligence process. You really do learn just about everything there is to know about your site, including what its strengths and weaknesses may be on the electric side. So if you got a site and you're wanting to kind of explore what would be a good fit, for that site, what it can, what it can accommodate, go through that, take a look at that certified site program, because it really forces you to ask those questions on the front end, much like Emily just pointed out.
Yeah, that's tremendous. Good job, both of you. Sherry, we've saved plenty of time at the towards the end here to talk about transmission. We're going to go to that next. I do want to remind the participants that the chat box is open. So I'm pretty sure I'm seeing, and we haven't had much yet, but we want to take your questions here in about 5 to 7 minutes. And then if we have to double back on some of this information, we certainly will, because we want to honor your time and get you out by 3. So I'll be quiet and let Sherry talk about the fascinating world of transmission. It's an integral middle part between generation and distribution.
Well, thanks, Jim. Yeah, not that long ago in pre-2000s, each utility managed its own fate, its own assets, including generation, transmission, and distribution. And that really each utility really had a narrow view of the overall grid, And so FERC, the Federal Energy Regulatory Commission, in spring of 2000 said, we really need a concept of an independent system operator. And so that was the birth of these power sales and markets called RTOs, or regional transmission organizations, or ISOs, independent system operators. They're interchangeable. And so the market began really MISO. We're sitting here in Iowa, most of it's in MISO. We do have a little bit into SPP, but those markets really came to fruition around 2005. So if you think about utilities that have been around and co-ops that have been around for over 100 years, we're talking about, these markets basically still being teenagers. And just like a teenager, they change their mind a lot and they have different rules, it seems like, and different ideas. So the concept is ever evolving, but it's brought a lot of continuity to the grid. And so the RTOs and the ISOs manage organized power markets by doing some very important things. They facilitate competition amongst wholesale suppliers. And so really this is way too simplistic, but those of us that are MISO participants, and so it could be an integrated utility like MidAmerican, it could be Alliant as a MISO member, Obviously, ITC is a member, but everybody sells their generation into the market. Then MISO determines those highways and byways on how to get the energy to the loads that they need to serve. And so then at the end of the day, you're buying the energy back out of the market. And the market is trying to do that very efficiently, the most efficiently, because they're looking at the grid as a whole. They also provide non-discriminatory access to the grid for transmission by scheduling and monitoring transmission. But the most important thing that they do that's better than trying to have each individual utility do it themselves, and that's performing planning and operations of the grid. And so they are to ensure reliability and also to plan for the future. So they also manage the interconnection of new resources. So all that Emily and Sam mentioned, all the renewable energy, that's not in one spot like it used to be. It's not a coal plant or a gas plant or a nuclear facility. It's distributed all over the place, and that requires transmission, requires those highways to get it to the loads where in your communities. And so they also manage those interconnection of both the generation and the load side. And then more importantly, they oversee competitive energy markets to guard against any market power or manipulation. And then they try to provide transparency of the transactions to the system so we all can benefit from the efficiencies of it. So MISO is one of the largest energy markets with $40 billion of annual transactions. And it also has some real competitive advantages. So I apologize for those economic developers in the far Northwest. I don't know as much about SPP as I do MISO. But MISO does have some competitive advantages that's really worked well as I've been out at conferences talking to site selectors, et cetera, those that maybe aren't as familiar with the power markets. But MISO's been a leader in planning for the grid of the future. Back in 2011, they came out with multi-value projects or MVP projects. And that was a portfolio of 17 projects that really helped strengthen the grid. And the best part about that portfolio is that that was spread across the region, across 15 states. So if you can imagine, if you were asked to do a project and your community had to be the sole funder of that, that's a pretty scary prospect. But when you're looking at it from a broader view and spreading those costs and allocating those costs across many, it makes for lighter work and lower rates. The beauty of the MVP projects is they quickly were able to show the benefit outweighed the cost and be able to do that cost allocation. So, and then in 2022, MISO approved $10.3 billion of portfolios of projects, again, to strengthen the grid across the system. And so, and before we even have one steel pole in the ground or pour any concrete or hang any wires, they're already approving a second tranche of long-range transmission plans that are estimated to be quite significantly more, $17 to $23 billion. So as the landscape is ever changing, as we're all answering RFIs for projects that are just astronomically larger than they ever used to be. And then we're diversifying our generation portfolio. You need transmission to make all of that work. And so MISO has tried to get out ahead of it, and I believe they're one of the ISOs that are way out ahead of it from their peers. The other thing that they provide us with is quick project approval, which is key. Speed to market is just everything nowadays to replying to projects. And they do have an expedited review process. Other ISOs like ERCOT and even the Southeast are taking months to approve transmission projects that are needed. And as Sam mentioned, a lot of these larger projects need substations. They need switching stations for a transmission, for the transmission provider, not only customer substations. That all has to be approved through these markets. And if MISO can do it, as little as in 45 days, others are taking upwards of 6 months. The other competitive advantage, I believe, to MISO is the renewable energy. Both Sam and Emily talked about their portfolios, how they're adding more. The customers are caring about that. MISO also has a view of connecting those customers as efficiently and quickly as possible. Now, there's a huge backlog. I'm not going to say they have it figured out, but they're willing to talk about queue reform and make that process smoother. So as they couple not only their queue, but their transmission portfolio of projects that unlocks gigawatts of energy that's going to be needed to serve new loads in the state. And that's really exciting. So I think that's one of the reasons we're getting such a great look right now across the state of Iowa.
Well, that's a really good recap. I would add that my little co-op happens to be in the Southwest Power Pool, or that Northwest Iowa portion of SPP there. And I would tell you that the RTO there is largely the same, advantages, disadvantages. I do want to point out quickly, though, before we get to questions, that this makes up the entire grid. So on you're looking at your screen, and all of these different power markets and regional transmission organizations have the ability to share with their neighbor through ties, the electric line ties. They're called DC ties for direct current ties between them. Then they have to have agreements to share, and if one runs short, they can buy from another, and given the situation, it's more complicated than that. Except for Texas and California, in this respect, ERCOT and CAISO, California, do not work and play well with others. So when you hear bad things about Texas in February 2021, and some warnings coming up in the summertime for them, they don't benefit from the trading of this capacity. We got to get to questions, although I don't see in the chat. So you can raise your hand, you can jump in with us. Otherwise, we'll take a minute here for questions. One that did come up in the chat, Sherry, while you were talking about transmission, was these how much they're appreciating the slides that are in there. These slides will be in under the resources. Carly added a link in the chat up early on in the session here. And if you click on that link to PDI's website, you're going to find the glossary we talked about. You're going to find this presentation recorded once they post it. It'll take them a few days to post it. And then also the slides themselves. So we're trying to give you all the resources we can on that. And so we want to be able to help them. And there she just reposted. Thank you, Carly. She just reposted it again. So there are all the questions are good as they come in. We've got about 5 minutes left, and I think the presenters have done a great job today of making sure that we get as much as we can get covered in an hour. But the main message, I think, folks, to correct me if I'm wrong, is get those utility people involved early and often. They have way more experience for you than just the electric side as well. So more heads in the room for planning these projects was always better in my experience.
Jim, while we're waiting, I guess you talked about the working amongst SPP and MISO. They do have a portfolio of projects they're called on the SEAMS projects. So in between the two regions, and there's some contemplated even with PJM. But as severe storms roll through, if we were more connected, we could have those resources. We do have energy flow east to west now, and we can help our neighbors. So it just helps us be more resilient and be good neighbors to our fellow market participants, and utilize all those resources as efficiently as possible.
Absolutely. Okay. We're going to give it just a couple more minutes. In the meantime, we have a couple of prepared questions or prepared topics to talk about that I didn't get to for the panelists. And I don't look back. One of them, I think, was Emily's. We're not going to mention numbers here, but what are the cost considerations? And everybody can jump in. What are the cost considerations to the project for, say, building a mile of line to a greenfield site? Of course, it matters the load, right? So what if I asked you for, we needed to build a mile of line that will serve a 500 kW, a half a megawatt size load. This would be sometimes a very large grain bin in a rural system. It could certainly be off of our chart from before, the smallest of data centers, probably not what they're talking about in a school building. Can you start us off, Emily?
Yeah. Yep. Just briefly, a couple of the factors, the answer is always going to be it depends, right? So what's the time? And obviously the load is so important. But just a couple of other things that we think about, is this overhead or underground? That highly impacts the timeline in which we can deliver it. So also, are there any upgrades to the substation because of this additional load? So those are the things that we'll have to think about, which again is why it's important for the utility to be involved before the project. So again, even as we think about the load, sometimes the amount of load, the revenue associated with that load will offset some of that cost of extension. So it's really important for, as customers begin to identify how much is it going to cost for us to do business there, or how much is it what's the capital investment? That is a great opportunity to offset some of that capital investment for that extension to the site. So again, that's why it's really important to keep us involved. Also, again, timing of the year. We live in a climate that changes quite frequently. So again, it's just really important to understand the timing in which that's required. So we can adjust a bit, when we're building that to accommodate for the season. Because if a customer has a need during winter months, that's certainly going to cost extra. And again, potentially, I guess anything can be done with time and money. But so again, we just really need to think about those things as we identify our capability of providing that.
Wonderful. Well, listen, we're bumping right up against time, and we want to respect the time of the viewers here, so we're gonna end it. I want to thank all of the panelists. They put a lot of work into this. There was some coordination that we wanted to make sure, so we got the month or the session right for you. Again, it'll be on the PDI website. We've got links in the chat right now. Contact your local utility provider representative with a question about anything about this presentation. Some of them were on here with us today in a participant role rather than the panelists. But Iowa has the advantage of great utilities, and some of the most reliable utilities. But certainly we've got the best economic development and key account people in the state to help you, the developer at the community level. So we want to make sure you're taking advantage of that. And tune in next week at this same time, this same link, for Sam and some of their folks as they go through an RFI. You don't want to miss that. Thanks again to the panelists and everybody for watching. Have a good day.